So before we get started, our team would like to recognize that this study occurred on the traditional territories of the Ktunaxa and Secwepemc, and we also thank our local communities, the Akiskimek First Nation and Shuswap Band, for their letters of support for this study. We'd also like to thank our former program coordinator, Amy Baxter, for her dedication to this project, and to those on our team that were responsible for sourcing the funding for it. We want to thank the Ready Grant, who funded a portion of this study as well. And we especially want to thank the community members who, when we were denied funding, stepped up and donated the majority of the funds to make this project possible. And now I'd like to introduce the scientists who worked on this project and who will also be our panelists for today. Heather Lorette is the principal biologist at Lorette Aquatic Consulting. With over 40 years of experience in areas such as water quality, environmental reclamation, and wetland development, Heather is a longstanding member of the Water Supply Association of BC and the BC Lake Stewardship Society, served on the Regional District of Central Okanagan Environmental Advisory Commission from 2003 to 2011, and previously worked with the BC Ministry of Environment. Jason Shalepe is a senior biologist and principal at Ecoscape, has developed foreshore inventory and mapping methods widely used for lake inventory, with expertise in terrestrial, lake, and stream ecosystems, has contributed to water infrastructure projects, source water protection planning, and integrating biology into land use and engineering. Jason's work includes numerous technical and peer-reviewed publications. Jamie Self is a senior aquatic biologist with over a decade of experience in water quality, project design, GIS mapping, data analysis, R programming, and algae identification. With a background in urban planning and experience with municipal and provincial government, Jamie has been with Lorette Aquatic Consulting since 2011. Luc Crevier is a GIS and data analysis and team lead at Ecoscape. With a strong background in biology and technical expertise in mapping and data analysis, Luc specializes in managing and interpreting biological and spatial data. His experience includes wildlife modeling, soil sampling, and diverse mapping projects, using tools like R and Python to streamline analysis processes. So I want to thank you all for being here today and for your work on this project. And now I will hand it over to you.
Thank you very much, Pam. First, I just want to say that we were very grateful to have the opportunity to participate in this work, right? Opportunities like this are few and far between, and the funding model, is an important aspect of this. So I do want to acknowledge the people that contributed, personal funds towards completion of this study. As a practicing biologist, I have been about 20 years experience. I have mapped 4,000 to 5,000 kilometers of large lakes in BC, right? So many of the large lower elevation lakes, Shuswap, Mara, Mabel, this one, Kootenay, Arrow. I've been around the shorelines conducting the foreshore inventory and mapping. So quite a bit of experience on lake biology, right? And am a true fish person at heart. Every pond we drove by as a kid, I would always ask my dad, is there fish in that, right? So I'm a true fish guy. And I have a passion for trying to make progressive change. So with that, I will begin. Slide. Okay, perfect. Okay, our presentation today, we're going to go a bit through the background, right? Build everybody up so they understand sort of the history and how we got here. I'll be talking a little bit about that. I'll also then talk about a little bit about the ecology of Windermere Lake. And then from there, we will transition to some of our other panelists. Luke will dive into some of the boat density calculations and how we worked to determine boat density. We will do our best to not try and be too technical on that front. There is quite a bit of technical nature to the analytical side of this, but we'll do our best to try and make it interpretable. From there, we'll transition over to Jamie, who will talk about lake health, right, and some of those things, and with Heather, and then on to summary and next steps. So broad overview of direction and where we're going, sort of a presentation outline. Windermere Lake. I mapped Windermere Lake 2 to 3 years ago now. I don't remember the exact year because I am getting on a little bit on the older side and my memory fails me sometimes. Um, it's a really shallow lake, as many of the residents know, right? It has maximum depths in the 6 to 7 meter range, right? Those depths are sort of on the borderline for some of our salmonid species in terms of temperature, right? When you have shallow lakes like this, they can become warm in the summer, and oftentimes that could be a challenge for a salmonid population. Given climate change and some of the other things, right? That sort of, mid 20s degree water temperature is actually really hard in salmonids, and some of them have a tough time making it go a bit. In terms of size, the lake is similar in size to many of sort of the moderate size, low elevation lakes, right, in terms of area. But again, when you look at the map, you can see that the deep water portions of the lake only encompass a very small percentage of the total area, okay, with that deep basin sort of close to the beach and towards Windermere. This lake has a flushing rate of 47 days. So what does that mean? It means that the total volume of water is replaced about every 2 months in this lake, right? Water comes in and water goes out. A lake like Okanagan would have a very, very different flushing rate, right? It has a lot longer residence time in the system. So a little bit of background sort of on the physical morphology of the lake. There's a couple of key tributaries and outflows, and ultimately this is at the headwaters of the Columbia system. When we look at the survey information that was done as part of this project, which was done by LWA, we asked residents and other people coming to recreate or use the lake a series of questions. That information has been summarized. It is in an appendix in the report and is available from the Lake Windermere investors. But here's a quick highlight of some of the key and core things. One of the big things on the lake was the vast majority of residents or people that took the survey, when they were asked what they used the lake for, non-motorized sport, such as swimming, stand-up paddleboarding, made up the vast majority of uses of the people surveyed, right? So it seems like there is a strong desire to use more passive types of recreation around the lake. On questions on boat density, many of the residents felt that having some type of maximum number of boats on the lake was a good idea, and that's at about 77%, right? The general consensus was that people felt that oftentimes there were a lot of boats on the lake, right? And sometimes maybe they were, it was potentially unsafe. So this factored into sort of how we approached the project, right? And obviously the survey was sort of happening concurrently with the work that we were doing. Personally, I have spent a lot of time on large lakes, and when I did the inventory and mapping project on this lake, I felt a bit of anxiety on the one weekend day that I was working. There were a lot of people on that water, and I found it as a small vessel operator proficiency. I basically have a designation that makes me a quote unquote captain, if you will, of a small vessel, not like a ferry or something like that, but I actually have taken some safety training. It's similar to your pleasure craft operators course, but a little bit more. And as a person responsible for my crew members, aka my staff and the volunteers that were working with me, I did find that the lake was a very busy lake compared to many of the lakes that I've been on. And that's just a personal observation. Again, I've mapped 4,000 to 5,000 kilometers of large lakes. I've put my time out in open water, and this one tends to be one of the busier ones. It would be similar probably to some of the smaller lakes in the Okanagan, like Osuyas, right, where you have a high recreational use and a lot of different people on the water on those long weekends. Another big concern that came out of the survey was the fact that it was very apparent that people cared about the environmental values around the lake, whether that was water quality, water quantity, species of birds, fish, wetlands, migratory flyways, etc. There was a strong showing that said that we care about our lake, which is great, right? At the end of the day, effective change comes when the people that live there or use the space want to do the best in that space. So hopefully I've done a good job of trying to sort of summarize some of the information that came out of the survey, right? So that we can sort of have a flavor of what people around that live around or come to recreate in the area, we're thinking about boat utilization on Windermere Lake. Ecology. Now I'm going to dive a little bit into the ecology. The backbone of the study was the foreshore inventory and mapping, right? The FIM, foreshore inventory and mapping, and the FHSI, the foreshore habitat sensitivity index, right, formerly called an aquatic habitat index, is a system of data collection that has been used to map large lakes. In short, the shoreline of the lake is broken up into segments that have equal habitat value or similar morphology, like physical morphology. It's a rocky shore for a stretch of 500 meters, or it's a sandy beach, or it's a cliff bluff scenario. There's different shore types, right? It's broken up into segments that have similar habitat characteristics or similar land uses. Then within each of those segments, data is collected on the physical condition of the segment, the riparian condition, substrates. There's a whole bunch of other data that gets collected, right? And so the lake then gets broken up into 30 or 40 segments. Each of those segments has data collected. That data is then used in combination with habitat data that is collected. And you can see those would be labeled such as things of zones of sensitivity in that foreshore inventory and mapping report. These were physical observations and or data that was provided to us by the province. And examples include mussel presence, right? If mussels were observed or beds of mussels were observed, they were marked. Why do mussels matter? The Federal Fisheries Act applies to them, right? They're incorporated and there's federal protection for any mussel species. High value kokanee spawning areas were mapped. All areas of aquatic vegetation and potential migratory bird nesting. Burbot spawning and rearing data was gathered from the province and digitized, right? And it is well known that this is a waterfowl migration corridor. So the FHSI and FIM, in combination with the zones of sensitivity and depth classifications, were used to look at the ecological importance, or another way to look at it is areas of higher risk, right? Areas that have higher ecological value would inherently have a greater risk, right, through utilization for recreation by people. So depth is a really important parameter. And how do we consider depth in this study? What we did to consider depth in this study was mine existing literature. And we used that existing literature to come up with and better understand what appropriate shoreline buffers would be. And one of the published studies that we read, which was on the lesser conservative side, there is more conservative classifications that I could have used, but I chose the one that was on the lesser, it was less conservative than other options, right? Was a 150 meter or 500 foot buffer. And you can kind of see that in that ranking when you come down, for instance, down to the south end of the lake. You can see sort of how the orange transitions to the yellow in the center. That's that 150 meter offset that you can see, right? So we use this published information to understand and set buffers to help scale the FHSI data and these zones of sensitivity, which when the data is collected in GIS, if you look at my hands, you have one data layer, I add another data layer, I add another data layer, I add another data layer. And where we get a high level of overlap in those data layers, this figure is more likely to come out red, right? So you can see down on the south end of the lake, we have a lot of red. Why? Because it's a migration flyway. We have a lot of emergent vegetation and it's very shallow. You can see in the middle of the lake before the deep basin on the northeast west side, there is a patch there. That's the burbot rearing area that came out of the FHSI data. You can see where the boat launch is, that little finger of red right there. That's where kokanee spawn, right at the boat launch. So you can see how all these different values, right, add up into a spatial map where we can better understand how boating risks relate based upon the physical presence of data, right? We have birds, we have fish, we have mussels. If you start to get lots of overlap of these different values, you're going to have greater overall value and much higher risk. So this data was used to understand as one layer what happens when you start to put boats and boat density over top, if that makes sense, okay? And as you can see, the least sensitive areas on the lake, areas marked as low or dark green, come out in the deeper water basins. Okay. Um, Hopefully I've done a good job of trying to highlight the values that were incorporated into the analysis to come up with this figure, right? There's a lot of data that is embedded in this figure. And I've tried to, the key criteria that were used are summarized on here. There may be some questions on this, and I am more than willing to try and answer it. It is quite a bit technical, but that's okay. I will do my best if anybody has any in-depth questions. So what can cause harm to these values on that map? One of the big driving mechanisms is sediment suspension. And I know that Heather and Jamie are going to talk quite a bit about this, so I'm not going to dive too far into that. But sediment resuspension in a shallow lake is a concerning problem, and it does have biological consequences, right? Boat recreation, and in particular wake boats or wake surf boats, they tend to create waves that have a different morphology than wind waves, combined with the fact that the intention is to make big waves, right? These waves can have an impact. And we've seen this in rivers as an example. I know the lower Shuswap River above Merrill Lake, they had significant erosion concern problems because the boats going up and down were creating a wave climate that the shoreline was not conditioned to. And when you combine that with the riparian losses or root mass that's needed to hold the stream bank together, right, you start to experience a lot of erosion, right? Erosion is a natural phenomenon. It does occur. When you add a whole bunch of boats on a water body, the quantity of erosion starts to go up. When you combine that with urbanization, such as retaining walls, you start to see the energy from these waves be transferred other locations because a vertical wall, the wave hits it, that energy's got to go somewhere, and you start to move that erosion around to other places. It can be concerning. There can be adjacent property issues and property line issues. It can be quite challenging for individual property owners to manage erosion that occurs on their property from something as simple as boat wake. There's a whole bunch of other, lesser effects that can occur, right? I mean, sound does scare fish, sound scares birds. All of these different things add up. Boats also act as a vector for aquatic invasives. And this is really important with the threats of mussel invasives coming in and causing substantial economic harm, right, to the tunes of millions of dollars, right, or more billions potentially. And Heather could speak more to this. There's a reasonable risk that if we don't manage boat recreation, that we could end up with harm in our water body. And I hope that I'm not saying that boating shouldn't occur. That's not my intent. Rather, I am trying to be honest about what risks are present and what this may mean for the community members that live there. So the important criteria that came out of the FHSI that are built into that map are these three values. The high value kokanee spawning habitat near the boat launch would be deemed critical habitat by federal legislation, right? It's not a very big patch and it occurs in an area of high disturbance, right? In a perfect world, that boat launch would actually be moved somewhere else, right? It's not a very good location for a boat launch as it relates to the habitat values that are present. Native mussels were identified and their beds were quite extensive. With the new Fisheries Act, as of 2019, mussels are included. There is actually protocols now for mussel salvage, if you will, in a construction project. DFO treats mussels no different than they treat any other fish. Okay, so mussels are also a really important habitat indicator. They have a complex life cycle. Typically, there's a bird, a snail, and a fish, or a bird and a fish, or there's multiple different hosts, if you will. They're actually a parasitic type of species. And they're indicative of a healthy ecosystem, right? If we start to lose our beds of mussels over time, it could mean that there's a concern there, right? Why? Because they have that indication type effect, because they have a very complex life cycle. And for them to make a go of it, everything needs to align. The bird needs to be there, the fish needs to be there, the water quality needs to be there for them to carry out their life history. The flyway side of this is really important. It's a really, really important waterfowl area. In particular, there's many types of bird species that create floating nests. They accrue vegetation, they make these big floating mats. And those waterfowl are extremely susceptible to boat wake and nest toppling, right? If you get a big enough wake, it can literally flip over the nest and that bird's clutch is gone for the entire year, right? Which can cause harm at a population level when you have important flyways that are critical for that population to make a go of it, right? Grebes in particular would be a good example of this. They're a fish-eating bird. They make the floating nests and they can very easily topple. Okay, so these are the core values that I think would be most impacted by heavy recreational use. And I hope that I've tried to point to the specific mechanisms that can where harm can occur. Right? I'm not just saying that boats can potentially boat wake can harm birds. Rather, boat wake can topple nests and flip them over and cause individual mating pairs to lose their entire clutch. Right? You do that for several birds. You got 10 nesting pairs on this lake, and those are the only nesting pairs. You lose 50% of those clutches. That's actually quite a big impact. And it doesn't take very much to really start skewing or having population level effects. Invasives, one more time. Windermere Lake has water quality that will allow for invasive mussels to establish. All it will take is one boat with a ballast or not a ballast, not drained dry, to come and release enough that a population gets started. That could be, oh, I'm going to empty my ballast before I go back because I got to tow my boat back. Well, emptying your ballast, in a wake boat case, that could be it. If that ballast was filled up and had veligers in it, could be the same thing as a boat comes up from the States or some other direction and they haven't drained it. And as I understand, there isn't any more provincial stops to investigate these boats. And all it takes is for them to just on the boat launch, undo their boat plug, and off it goes into the system. That's it. So the risks are there. And I've seen in the Okanagan, as an example, hundreds of thousands of dollars be spent on public infrastructure projects already, preparing for the fact that mussels may come, right? Big public infrastructure water intakes, designing systems around to make sure that they can flush out and get mussels off if their intake is affected, right? It's a really important thing and can have a very significant impact on both habitat values and most likely the local economy. And with that, now we're going to dive into some of the more technical stuff. Okay. Luke's going to start talking about boat density, and I will tag out and put myself on mute.
Thanks, Jason. Hello, everybody. It's really encouraging to see this level of engagement in this project. So thank you for choosing to spend some of your afternoon here with us today. So Jason's right. I'm going to be talking a little bit about the collection of boat data. So we're looking at boat counts and spatial locations on the lake. The reason that information is useful is that it gets at a few points. How many vessels are actually on the lake from day to day? Do we have days of the week or times of day that are more popular for different types of recreation? We can also speak to where people are recreating most frequently. So are we seeing hotspots where there is a lot of activity? We can relate that back to our habitat values and ecological concerns. And then, of course, there's the safety perspective. So high boat densities can be a safety concern. More vessels with more users actively recreating may increase the likelihood of incidents. So to get at that information, the Lake Windermere ambassador staff and volunteers put hours and hours into collecting boat data. That sampling effort started in 2022, and the first effort was set up to get systems in place, sort of to ensure that the right kind of data were being collected. We provided grid-based maps so that staff and volunteers could spatially log the locations of any of these vessels observed, and we had structured tables with specific rules on the data format that should be collected about each of the vessels observed to ensure that we have really consistent data. And in this way, like Windermere ambassador and staff and volunteers captured where the boat was on a given date and time, what kind of boat we were looking at, and what the boat was actually doing. So this approach was structured but flexible, and the data and feedback from this first effort was used to refine data collection for the following year, 2023, when most of the data collection proper occurred. And in 2023, data collection moved to a digital format where we're using ArcGIS Online to capture points and data directly. So volunteers and staff had tablets, and they were able to log spatial locations of vessels along with the information required about the boat types and activities. This database is established, set up, and stored online, so logging any further years to improve data accuracy is going to be, possible and straightforward. So if there were interest in building a longer-term record of boating activity on Windermere Lake, that's something we can tackle fairly easily. Pretty big effort. 31 individual sampling days over the 2 years, with a total of around 1,600 individual vessels logged. The red dots on the lake outline on the left indicate those individual observations. And you can see even just qualitatively, there's clustering and high density at the northern end of the lake, with use tapering off towards the south. Sampling effort was scattered, occurred at different times throughout the days. I've got it broken down in this barcode plot by weekday, weekend, and long weekend. So the translucent gray bands on that barcode plot indicate times when sampling occurred on the different days. So darker gray means that there was overlap, more than one sampling occurred at that time frame. From that data, we can start to pick at information like boat type and activity. So we can look at overall lake use. This figure that we're looking at now is a kind of heat map where colors that are closer to yellow indicate higher counts for a given boat type and activity. Colors closer to dark blue indicate lower counts, and white indicates no observations at all in that category. This kind of plot lets us pick out how often different boat types are doing different kinds of activity. For example, we can see here that paddlecraft are unsurprisingly spending a lot of time in the paddling category, but this also highlights that the activity of different vessels can vary a fair bit. So we have wake boats that are frequently observed generating wakes, power boats that are frequently observed traveling quickly, but we also can see that wake boats and power boats are commonly logged as stationary, with users swimming or just relaxing in the sun, something like that. We can also look at boat type and day of the week. So when are users recreating? Again, breaking that down by vessel type. And again, we have closer to yellow indicating a higher count of a given boat type on a day of the week. Colors closer to dark blue are the lower counts, and then white indicates no observations in that category. Unsurprisingly, in general, people tend to be out on the weekend across all boat types. We can also look at time of day when people were recreating with the different boat types. And in this figure, we have a y-axis on the left and right indicating the time of day, and the x-axis on the bottom is indicating the count of vessels for each boat type. So bigger bars indicate a higher count of boats for a given time. In general, it seems like there was a spike of powered vessels centered around 10:30 a.m. or so, and then another larger one around 3 p.m., whereas it seems as though the use of paddlecraft is a little more uniform across all types of day. But it is important to note that this pattern is at least partially due to when sampling occurred. More boats may have been logged in those times simply because that's when recording was being done. If it were required for some reason to better understand the actual breakdown by time of day of different boat use type, we may need to do a little bit of additional sampling, which may come from a longer longitudinal record as well if we were to extend that database that I was talking about earlier. This also lets us look at spatial density. With spatial records, we can look at the where of these boat observations. This map set highlights more or less the same thing that the individual boat sampling showed, where boat use tended to be concentrated most heavily in the north end of the lake. Those yellow and red spots are a way of looking at boat density. So a common threshold for boat safety when it comes to actively recreating powered vessels is that you need about 20 acres per vessel. This is referred to as the carrying capacity. And in this case, we're looking at a view of the map or the spatial observations that shows any places where in a given sample time span, there was a boat density higher than that one boat for 20-acre threshold. In other words, where locally did boat density exceed what may be considered safe or the carrying capacity. This isn't a perfect snapshot of a moment in time since we are looking at sampling events and including vessels that are not necessarily actively recreating, but it is a way to identify those areas in Windermere Lake where density may be of concern. Here we're looking at all vessels for weekday, weekend, and long weekends, but we can also tease out individual boat types. So we can look at motorized vessels, which is not a super dramatic change from the all vessels type because current use, this is the most common vessel type on the lake. We can also look at wake boats, same kind of pattern, just with our density highest at the north end and then tapering down towards the south. And then finally, we can also look at the non-motorized vessels. And here, the 20 acres per vessel guideline is really not applicable. And instead, this map is more useful to highlight where the non-motorized vessels tend to congregate. And I will pass it over to Jamie, theoretically.
I think I've got it.
Thanks.
All right. So in this next section, we're going to change gears a bit away from kind of the boating recreation side to more of the what's going on in the lake, water chemistry, sediment chemistry, and the data that we were collecting on that front. And so this focuses most specifically on the data that we collected during our field monitoring, but we do include some longer term data from the Ministry of Environment. So we'll start off sediment traps, and these are a type of equipment that we use to notice there's a picture here of what one of them looked like when we retrieved it from the lake, and then kind of a schematic where you see what exactly it is. It's very simple. It's just a funnel that focuses sediment into a collection vessel. So we'll talk a bit more about what that is. So sediment traps were deployed throughout Lake Windermere in September 2022 to measure the rate of sediment was accumulating on the lake bottom at various locations. The goal was to try and correlate the sedimentation rates with local features, such as stream inflows or areas of higher human activities, to just try and see if there was any geographic distribution where we could identify this area has higher sedimentation rates than this area, and if so, why? And I mentioned human activities. Here's a drone photo. Actually, I think it was from an airplane of a boat wake plume leaving a marina on Windermere Lake in 2023. So you can see that obviously the sedimentation rate in this area would be increased. Unfortunately, the number of traps were lost during the trial run. 8 traps were initially deployed, but we were only able to retrieve 2. And so the loss of these traps made kind of teasing out some of these geographic potential patterns inconclusive, unfortunately. Here is just a map of where we did the sediment monitoring. You can see we did sediment cores at the white diamond shapes, and we put the sediment traps at the orange circles. And again, most of those we were never able to find. Sediment samples from Lake Windermere were analyzed for a few different things, but first of all, we'll talk about metals. In 2022, we did that. So kind of a little bit of background. When metals enter a lake, either naturally or through human sources, most will very quickly deposit into the lake sediment. And there's a number of mechanisms that will cause that to happen. But metals, once they get in the sediment, can then be resuspended into the water column and become available to be interacted with through wind events, lake overturn. And those would be natural kind of mechanisms for resuspending sediment. And then some human impacts, actively disturbing the sediment, but also boat prop wash and wake turbulence, as we saw in that last photo from the airplane. The type of sediment in the lake can make a big difference on the types of metals that will be present in it. Clay and organic sediment, think black goopy mud, will better hold on to metals than sand and gravels will. And we'll kind of touch on that has a geographic pattern in the lake, actually, which we'll touch on in the next slide. Just kind of some highlights of what the results showed. Copper and lead were both below the regional guideline concentrations, um, but they exceeded what is called the trigger threshold, or 80% of the guideline. So what that means to say is that it didn't exceed the guideline. We're not expecting aquatic health concerns from those, but they are close. So they're not nothing, but they're not immediately concerning to us. It's just something to know there. Exceedances were detected, so these would be aquatic life sediment quality guideline exceedances, focusing on how the quality of the sediment affects aquatic life, not specifically human activities, but there were exceedances for arsenic and nickel were detected in a number of locations throughout the lake. However, these concentrations were within the lower range of what is regionally seen in other unaffected lakes. So we're kind of attributing that to, at least in part, geological considerations. And again, I did mention that metals do also have natural sources. It's not just human activities. We'll skip to the next slide here. So this is just a summary table, lots of numbers for those inclined. And we're seeing here we've got the metals of interest, kind of the ones that popped out as most important in the data analysis. The next column we've got here is sediment quality guidelines. Again, I mentioned these are the aquatic life sediment quality guidelines for British Columbia. Then we have in the third column the mean and the range you would expect for natural uncontaminated lakes in this part of the province. And then the final column, we're seeing the data from Windermere Lake. You'll notice the units are different, but they actually work out to being the same. Microgram per gram is the same as a milligram per kilogram. It's just that's what's listed in the literature, and this is what comes back from the lab. So we can see where that the metals in Windermere Lake are not on average higher than the regional background, thanks to its lack of industrial activities in the watershed and few major urban stormwater discharges. Iron and manganese, that would be Fe and Mn here, were both above the average for the region because of low oxygen conditions in the lake sediment. So that would refer back to when I was talking about the black organic mud that decomposes and sponges up oxygen in the lake's deeper basins. This is a natural phenomenon and occurs in many lakes, whether people are there or not, but it can be exacerbated by human activities such as eutrophication, which is something that I'll talk on in a couple of slides. Here is just kind of a summary map highlighting the geographic patterns of where which metal was most common in the lake. And the important kind of thing that you'll notice is that we have this green area in the middle, which is to say that metals were on average lower there. And the reason for that is because the sediments in this area were much sandier because that's where Windermere Creek enters the lake. And so you get this accumulation of sand in that area, and therefore metals tend not to accumulate. But in the softer, deeper North Basin and the shallow, silty South Basin areas, we can see that metals were on average higher. And the reason this is relevant is because we'll see that some of these areas where metals are higher also overlap with where recreation activities tend to be most prevalent. These next maps, very similar to the last one, but this is, instead of metals, we're looking at sediment hydrocarbons. Sediment hydrocarbon contamination potential was also assessed during this study. And the early results in 2022 suggested there was a concern for hydrocarbon contamination. Basically, we did a few samples and got back some results that said hydrocarbons were in places that we weren't expecting that they were. So that a little bit of a flag there. So the next year we did a much more thorough investigation, many more sites, more parameters, and looked at some things that instead of just general hydrocarbons, we looked at more specific parameters of concern, PAHs and things like that. And once we got back the data from the more detailed survey, it really illuminated the subject, and we concluded that widespread hydrocarbon contamination is not actually a significant concern in Windermere Lake at this time. So that's good news. Next. So I had mentioned previously one of my slides, the idea of eutrophication. So that is a concept on the nutrient status of a lake. And overall nutrient concentrations in Windermere Lake are mesotrophic. That is to say, the concentrations are sufficient to support relatively high algae productivity. Higher algae productivity, in particular, the growth of cyanobacteria, can cause significant health concerns if they become too abundant. The shallow nature of Windermere Lake and its fine sediments increases its natural susceptibility to increased nutrients because of more frequent sediment resuspension. But human activities, again, can exacerbate this. The data indicates, so we're looking at the second panel in this graph here, TP, or total phosphorus, is the limiting nutrient. That is, increasing or decreasing the concentration of this particular parameter alone would directly lead to greater or lesser algae growth. And you can see the dashed red line here. That is the water quality objective for total phosphorus in this lake. And you can see that we do, in the last 8 or 9 years, we have exceeded that threshold a couple of times. Fortunately, in the case of Lake Windermere, as Jason mentioned in one of the earlier slides, there's a very high flushing rate, so nutrients don't tend to accumulate year over year as you might see in a much larger lake, which works in our favor. Connecting nutrients up the food chain. We'll talk about phytoplankton here. So phytoplankton are free floating algae as opposed to algae that grow stuck on rocks, rock slime, that kind of stuff. And the community composition was measured at 4 sites within the lake during our study. The densities were moderate in the southern sample sites, while the northern sites had very high densities and were dominated by potentially toxic cyanobacteria. The beach sample, this would be the main beach at Windermere in particular, contained 21,410 cells per milliliter, a number that I'm sure means nothing to any of you, of cyanobacteria. And this is actually a concerning result from us for a popular swimming area. You can see here we've got the second pane in the graph here, we've got what we call a riskometer type graph. And you've got categories based on the abundance of cyanobacteria. So 0 to 2,000 cells per mil is effectively no risk. 2,000 to 15,000, you've got a very low risk. 15 to 50,000 cells per mil, you're seeing moderate risk of production of cyanotoxins in a bloom of that density. And then above 50,000, there's real concern for exposure to cyanotoxins. So we were in that moderate risk category, the low end of it, but still within it. If nutrient concentrations increase, particular phosphorus, as I mentioned, that's what we call the limiting nutrient in this lake, those summer cyanobacteria blooms could become more problematic for Lake Windermere. Sediment resuspension, bringing it back to this thing that we've mentioned a few times now, presents a rapid localized release of nutrients from the sediment. When you stir them up, you get this plume of nutrients available. And other researchers in the literature have found that total phosphorus levels, increased by an average of 25% with only 2 passes of a wake boat in surf mode in waters of comparable depth to what we found in Windermere. So kind of the important take home in the lake health section is that Lake Windermere is naturally vulnerable to increased nutrient concentrations, particularly from nutrients released by resuspended sediment. Powerboating is well established in the literature to increase sediment resuspension, and we have seen it ourselves on Windermere Lake. And we can therefore draw a link between sediment resuspension and boating to increased algae production and therefore increased risk, health risk associated with harmful algae blooms. And now I will pass it over to Heather to take over the next section.
Thank you, Jamie. I think you've probably gathered by now that the Ecoscape team and the Laird Aquatic team want to see your passion for Lake Windermere translate into timely and effective change. The lake is showing evidence of stress on a number of fronts, and we're keen to intercept and maintain the quality that everyone appreciates out of Lake Windermere going forward. Next slide, please. Thank you. This looks a little bit scary, but basically what it is we wanted to develop a way of ranking lake suitability for powerboating in answer to a comment actually made in one of the meetings we had with Lake Windermere ambassadors, realizing that it's always better to tell folks where they can go to play when they're out on a lake and not where they can't. So what we did was we tried to rate lakes. What lakes are really well suited to powerboating, if those exist, and what lakes really aren't, and why. And not to do it just based on what I think, but using the very latest and greatest water science literature and creating these categories where we assigned a numeric value, as you can see in this table. I would love to dive into the innards of how we arrived at all these numbers with you, but I'm sure we would bore the majority of people here silly, so we can tackle that offline if you like. All the risks and concerns raised in the Lake Windermere Recreational and Sediment Study that we're discussing today fed into this ranking system. So if you just skip to the most interesting stuff, the bottom line, you can see that there's only 2 lakes that ranked out as extreme risk from motorized recreation for powerboating. That was Duck Lake, which is extremely shallow, similar to Windermere actually here in the Okanagan. And as you might have expected, Lake Windermere's ranking was also severe, which according to this ranking system and the latest literature, it'd be unsuitable for powerboating, where prohibitions or limits on boat density, boat power are appropriate. Some of the other lakes, they're at considerably lower risk. So once again, just to recap what we've been going over, and I appreciate your patience with all this science if science isn't usually your thing. This study confirmed that there are threats to the values of Lake Windermere. My staff commented to me the other day that of all the lakes that they'd ever worked on, when they were working on Lake Windermere, collecting some of this data, they had more people coming up to them, asking questions and expressing concern about the values that they treasure in Lake Windermere. So it's kind of funny how hard scientists have to work to prove what is intuitively obvious to the informed observer. So what you've heard this, and you're going to hear it one more time, sediment resuspension creates an unusual nutrient release. Lake sediment should be the place where nutrients and contaminants go and get buried and they're lost from the system. But we have now invented a new way to push them back up and bring them back into circulation on top of what's already still ongoing and moving into the lake system. The algae that Jamie mentioned, the cyanobacteria, that count on a beach is a little concerning, or a lot concerning. And it seems counterintuitive, but inhaling the aerosol of water that has a high density of cyanobacteria is actually more dangerous than drinking the same water. And for example, Skaha Lake in the 1960s was making water skiers sick because they were inhaling the aerosol that contained cyanobacteria, with children among the most vulnerable. And this is not something we want to see happen here. Lakes aren't things that we can break and then say, oh, oops, and go fix them. The loss of a lake value can be permanent, and it can carry a big aesthetic and financial loss to the community. If Lake Windermere were a deep lake, the theoretical boating capacity would be 200 vessels. But it's extremely shallow, so that doesn't work. And even at the boat densities that were shown in this study, we exceeded that. This study lays out the amount of lake area available for power boats and wake surf boats based on criteria that are in use in North America. In other words, we didn't make up these thresholds. Wake surf boats are now in their own category with Transport Canada because of community concerns raised across Canada. To no one's surprise, Lake Windermere exceeds the safe boat carrying capacity, as we mentioned. But I want to emphasize here before we dive into the, well, if you set the categories here, this is what it looks like, that the power to decide how Lake Windermere is used starts with the local community, including First Nations and Windermere, like the folks that have the most invested. It's not our role as a research team to tell you how to best manage the lake that is so near and dear to so many of you. So for example, if we use 4 meters and deeper for power boats, you go dead slow until you're in 4 meters of water, and then you carry on and have some fun in the play zone. 43% of the lake area is available for that, or 97 power boats. So we're already just descending from that 200 number if Lake Windermere was, say, 30 meters deep throughout. But it also follows that paddlecraft then should stay 4 meters and shallower. And if they go out beyond 4 meters of water, they should view themselves as guests that are in the play zone for the power boats and behave accordingly, respectfully. If we decide to use water at or deeper than 6.5 meters, this is an American guideline for wake surfing, and 150 meters from shore, or 500 feet, the approximate area drops to 4.6% of the lake area, or 9 wake surf boats. If we use water deeper than 8 meters, which incidentally is give or take, a 3-story building, we have measured in the Okanagan and a number of places around BC that the more powerful wake surf boats, when wake surf mode, the vertical jet that they create actually disturbs sediment 8 meters. So it's not an arbitrary number. If we choose the 8 meter, Windermere just isn't that deep. So none of the lake is available for wake surfing. So if we move this onto mapping, this mapping is in the appendix of our report because, like I said, it's not our place as a consultant team to decide how Lake Windermere should be stewarded. That decision, in our view, belongs first to the residents. You folks have the most to lose. What is our place to say is Lake Windermere is showing overuse stress on several fronts, and the risks of loss, such as algae blooms making people sick, is increasing, as is the risk of accidental introduction of invasive mussels, which is a terrible and irreversible loss, both ecologically and economically. So the left-hand image is the more conservative approach with the greater than 8 meter guideline for wake surfing. And you see outlined there a powerboat play area, which is fairly large and actually encompasses where most of the boats powerboats were located, but nothing for wake surfing. The more risky approach is on the right, if we use the greater than 6.5 meter guideline for wake surf, and you see that little tiny purple blob up at the top of the map. Powerboats need to proceed dead slow in their play zone to avoid sediment scour, so that was so visible in the drone photos. And paddlecraft need to stay out of the powerboat play zone. This has to be mutual to work. And we're very hopeful that people can start to adopt these practices anyway, and will start to remove the scour that we're seeing in the imagery. So we began to conclude from all of this that Lake Windermere is not suited to wake surfing, and powerboating requires a boating capacity number assigned to it with a mechanism to limit the number of powerboats operating on Lake Windermere through the summer. Lake Tahoe is an example that has had to go to this. It now limits the number of boats that can be on Lake Tahoe at any one time because of the damage caused by exceeding Lake Tahoe's capacity. These concerns are being mounted worldwide as tourist destinations grapple with over-tourism. So finally, we've created some recommendations. This is a very wordy slide, my apologies, but the most important thing here is right at the top, and that is create a Lake Windermere stewardship plan. This is a legislative tool that can help guide how Lake Windermere is managed moving forward. And this is constructed by locals with all the stakeholders at the table. That's really, really important. And this table is set from most preferred, least heavy-handed options towards the top, and least preferred, more heavy-handed options towards the bottom. Personally, in the end, I believe that everyone's goals for Lake Windermere are aligned. Everybody wants to see the lake continue to be a healthy, pleasurable place to recreate. And although it may not seem like it in the short term, in the long term, lake health and the economics of an area are always aligned. So I think the first place to land is to re-educate. So number one is to explain to folks what's at stake, as Lake Windermere ambassadors and others have tried to do. Most recreators don't want to damage the lakes they enjoy. And that we need to consider reserving sensitive areas and perhaps sensitive windows of time that are shallower than 4 meters for wildlife and for paddlecraft. If we can't come to voluntary agreements on Lake Windermere protection, then the final resorts of regulations, restrictions, and enforcements may need to come into play. Because Lake Windermere is showing strain, and a course change is needed, and is needed now. I want to thank you for your kind attention. Unexpected stuff does, in fact, happen, like the crazy weather events that sink boats on Lake Windermere. And we want to stop to thank the people that care enough about this to volunteer, the Lake Windermere ambassadors, and all of you that are attending, and everyone that's contributed financially to this program, where we have tried to undergird the concerns that everybody knew with some science. Thank you very much.
Thank you, Heather and team. We are going to take some questions now. We have quite a few already in the chat box. So if you do have any questions for our panelists, please type them in the Q&A box and we will relay them to the consultants for answers. So we'll just start at the top here. So we have our first question from Mike. Ecoscape is from Kelowna and has no local expertise. It appears the consultants relied solely on LWA members for this local knowledge. LWA is well known as having a severe bias against powerboating. In order to get the best study results, why did the consultants not reach out to other groups for local knowledge?
Okay, I'll take that one, Pam.
Thank you.
I mean, first, I do have experience on Windermere Lake. I did the foreshore mapping project. I spent 4 days on 11 or 12-hour days on that lake as part of the foreshore study. That was prior to this study. For reference, I have sampled close to 200,000 fish or more from the Okanagan Lake system. The system is very similar in terms of the fish assemblage. I've also done lots of work for BC Hydro on the Columbia system with Heather as well. So I do have experience on the Columbia River system. I encourage anybody that feels that we have been professionally negligent or are acting unbecoming as a professional, I strongly encourage you to go seek out the College of Applied Biology. Every person sitting here, I am bound and have a professional duty to the public. Okay. And my duty to the public is to provide honest, clear answers about habitat or biology within my lane, right? And my lane is fisheries and large lake work. I believe I'm practicing within my lane. I believe I have the necessary experience to conduct this work. I have over 20 years experience. I've mapped 4,000 to 5,000 kilometers of large lakes in BC, and I've sampled a lot of fish. So if you still believe that I have insufficient experience or lack the knowledge to capably undertake this work, I encourage you to go talk to the College of Applied Biology, right? That would be the mechanism that any resident has here that feels that we as professionals are not conducting ourselves in a way that professionals should. The Professional Governance Act of 2022 is a very powerful piece of legislation. It ensures and keeps all professionals in BC honest. So if you feel that we aren't doing a good job, that's okay. You are allowed to have those feelings. Please go to the college. That's how things improve. If you truly believe that we are not acting appropriately. I hope I've answered that question. Well, I do believe I have the necessary experience. We may just have to agree to disagree.
Thank you. Next question. Implementing the recommended steps will cause a severe economic downturn in the valley, yet there is no economic impact assessment included. How can Ecoscape make the recommendations without considering economic consequences?
Ironically, I'm going to go right back to the Professional Governance Act. I am not an economist. I cannot provide any comment professionally on economic considerations. If you want my personal opinion, yeah, there are potential economic consequences here. Having said that, I'd also suggest that over-tourism is a well-published entity these days. There are systems out there that have experienced so much tourism that people aren't coming back because they don't want to go there anymore. So it's equally possible that too much tourism can be a bad thing. I don't want to comment on the economic side of things. It's not my lane. I agree. There are economic risks associated with that. That's probably part and parcel with what the community needs to consider as they go forward. It's an important part. The lake is your lifeblood. And if it's your lifeblood, you want to make sure you do good by that. That involves managing the economy, managing the environment, and probably managing what expectations are. So that would be my advice on that one, is it probably is worthwhile looking into the economics of tourism and what the boating industry does bring and what would happen if there were changes to how that boating industry worked. It's a good question, but we can't comment on that. And professionally, I would be negligent to put that in my report. And if I did, that's a place that someone could definitely submit a complaint and I would find myself in trouble as a practicing professional.
Great, thanks. So next question, also from Mike. What is the definition of wake boat versus power boat?
And again, I'll take that one. Wake boat was defined as something that had a ballast, right? That added wake and had the intention of generating a wake when recreating. The data was collected in such a way that if it was not known if it was a power boat or a wake boat, it defaulted to power boat because that would be the less risky of the two. So it was done by volunteers and they had to be confident that there was a ballast or some type of weight adding feature to the boat to be classified as a wake boat. Probably brand was used to do that in the field. And when in doubt, instructions were to err on the side of power boat if you didn't know. So power boat, a good example would be a 18-foot aluminum fishing boat with 115 horsepower motor on the outback. Hughes Craft say that's what my boat is. That would be just a power boat, right? I don't know wake boat brands very well, but I know that they have the big ballast tanks in them, right? So it has to have a ballast tank.
Thank you. We have a question from Arlie. Where does the safe boat density come from? Is it based on BC guidelines or research or where?
I don't remember the exact publication, but there's two references that are in the report. Heather, do you know off the top of your head?
I don't, but the boat density that was considered safe is a standard that's used. I'm sorry, I'd have to look it up, but certainly it's in the report.
Yeah, it was not derived by Ecoscape or Lorette. We used literature, published literature values for that. and erred typically on the conservative side of those values, aka if there was bigger areas needed for boat wake recreation, we tended to choose the smaller areas within the published literature to be conservative, to make sure that we were not over or underrepresenting boats or not boats side, if you will, for lack of a better way to put it. We approached it as unbiasedly as possible.
Thank you. Arlie, if that doesn't answer your question, you can email me at info@lakeambassadors.ca and we will find where that came from. Thanks.
Yeah. I got this next one, Cam. Yes, there is a correction that is needed. The map that was shown is different. The reason for that, Luke and I were chatting back and forth about. We don't quite know. The map shown in the presentation is the correct map. People that want to understand how those differences occur, when we work through the data in a spatial sense, we run iterations of the different models and then use professional opinion to calibrate that, if that makes sense. So no, we have not collected statistical data for some of this. I have seen people talk about statistics, and the difference is, the best way to put it is, if I need to use stats to answer questions, your budget will go up orders and orders of magnitude, right? Data acquisition is very expensive. It's why Luke brought up the database is set up, and there is benefit in residents or people that have a concern to continue to collect data over time so that you get better data to better answer the questions, right? Data acquisition is always the most expensive part of these studies. And in this case, citizen science was used, because if we didn't use citizen science, our budget would have been over $100,000. It would have been $200,000 or $300,000 probably to do this. Oh, you're on mute, Tom. You're on mute.
Sorry, thanks. All sediment is within guidelines and geographic geology considerations. No contamination is evident, correct or not? I'm guessing that's the question.
Yeah, that would be
I can take that one. So no, not all sediment was within guidelines. We did see sediment quality guideline exceedances for arsenic and nickel. But referring to the second part of that question, the range of what is expected in natural uncontaminated lakes in this region is, broad, because there's many different kinds of lakes, and Windermere was within that. So exceedances can happen naturally, I think, is what we can say. But we don't see any huge exceedances that exceed and go outside of the range of what is in natural uncontaminated lakes in this region, if that makes sense.
Thank you. So our next question is from Ross. They're wondering which main beach you're referring to in the presentation. Is that Kinsman, James Chabot, or the Elthamer boat launch?
Kinsman is the typical beach. When I said main beach, it would have been Kinsman, where the high boat density was observed, right? All the beaches tend to have a higher boat density, but when I say main beach, it would have been Kinsman.
Thank you. Next question is from Christine. Could fixing the sediment erosion event from Windermere Creek help improve the levels of sediment deposits? Why was that not noted in the recommendation?
Well, I think, Jamie, you can probably speak to this as well, but we were focused strictly on the lake. When you're looking at reducing the sediment load coming in from a creek, you're looking at the riparian areas along that watercourse. And that unfortunately was not part of what we were able to study here. But it's very true that if you have an intact riparian area on both sides of a creek, you will reduce the sediment load coming in. Having said that, all creeks do deliver sediment to lakes. So that's a fairly natural process.
I think too, there is differences between the sediments, right? The lake sediment, or the stream sediments coming in from the creek, okay, they would be bringing in their own nutrient load, right? Whereas the lake sediments are going to have a different nutrient load. And how do I assuming that event, I've heard of that event. I don't know if that was a naturally caused event or not, right? But let's just assume that it is a naturally caused event, right? That's different than the ongoing sediment resuspension that happens from boating activity, right? That boating activity is liberating nutrients and or metals that have been locked up in the sediment for a long time. It's actually changing the chemistry. Natural events occur. That's a one-time event where you had a flash of nutrients come into a system from an avulsion on a stream system. It happens. To me, that is dramatically different than a boat wake resuspension of sediment that is continuing to liberate nutrients or metals that were locked up on the lake bed and not biologically available. It's making them now biologically available again, which alters your water chemistry. So I hope that I've tried to explain the difference between the two events. There is a difference between them, right? And the lake's response may be the same, but the sediment resuspension from boats is one that is adding new nutrients or adding locked up metals. And by locked up, I mean they're bound up in the sediment. Biology can't get at them, right? Like they're there, but they aren't doing as much. When they enter that water column, they are now biologically available. That's when risk goes up. And so by liberating these things back into the water column, we're actually altering the concentrations over time in a different way than what would happen in a natural system. Hopefully that helps a little bit.
Next question, could you comment on the potential impacts on lake health of powerboat activity at a lake like Wassa, given its smaller size, shallow depth, soft bottom, and lack of surface water flushing?
It would probably be very, very similar to this one, right? Any shallow lake, okay? Duck Lake in the Okanagan is similar, right? Any shallow lake that has high recreational use has the potential for the exact same mechanisms to occur, right? It's not, this isn't just a this lake problem, it's a shallow lake problem, right? Shallow lakes in particular have greater risks than deeper lakes. In short, what you see happen is there's a change in trophic level, if you will, right? You have oligotrophic lakes like Okanagan or Shuswap. These are deep, tend to be clear lakes. They are not as productive. And what do I mean by productive? Think about your typical food web, algae on the bottom, then you have your invertebrates, then you have your fish, right? More productive lakes, the bottom is a lot wider. The pyramid is a lot bigger, right? More productivity means you can make more biomass, right? What happens in lake succession is you go from oligotrophic to mesotrophic to eutrophic. As those trophic levels go up, your nutrient regime is changing and the different communities are changing within. Shallow lakes tend to fit in the meso to eutrophic range, right? And those lakes are a lot more prone to water chemistry changes where nutrients are released. And what can happen, and this is Heather, where you come in, what happens when we release a bunch of nutrients to a lake?
Well, it kind of actually feeds into one question down, which is like how Ariel? Alexander asked, how is water temperature related to cyanobacteria? That's a really good question. Water temperature is really super important, and I'm not intentionally dropping a question, but the main driver for cyanobacteria is phosphorus. And so if you release a lot of phosphorus out of the sediment, you add that to what's coming in from various communities and other sources, you're exacerbating the problem and making it significantly worse. So the main driver for cyanobacteria is phosphorus. Secondary is temperature. You are correct. But you could notice that the samples that we took, we only have one set of samples from Windermere, so we can't extrapolate beyond that. They were those collected in September. They weren't collected when water temperatures were at their peak.
Thank you. Next question is, how do the particles coming off the trains affect the lake as compared to what is focused on being boat traffic?
I'll take that one. Any form of urbanization has potential to cause impacts or changes to water quality. For instance, there's this new study that come out of Vancouver where they're looking at one compound in rubber tires, And that one compound has been enough to significantly impact co-host spawning survival of the spawned out eggs. Like it's actually clearing out creeks, and that's just from simple road runoff coming from bridges. So is it theoretically possible that train dust can have an impact? Yeah, right. You add that to the list. Heather brought up stormwater, right? All of these point source discharges or non-point source, in the case of a train, it's a long linear length and ongoing cumulative impact. They're going to add up over time, right? What happens is all those materials, they enter the water course, they sink to the bottom eventually, and then that's when the sediment resuspension problem kicks in. So if there is a contaminant, let's just use the rubber tire one because I don't know about trains, but let's just assume that we have a whole bunch of that contaminant from the rubber tires that's come off in stormwater and it ends up in the sediment. As soon as a wake or a natural wind event pushes that back up into the water column, it's now biologically available again and harm can reoccur. Okay, so there's this really important process that happens over time, right? And we see it with chemicals like DDT, right? DDT is locked up in lake beds, right? It's down, it's getting lower down now. It's not as risky anymore as what it used to be, right? And we're not applying it, right? If we liberate that sediment, we can easily bring that back into the water column and make that another problem in the future, as an example, right? So hopefully I've answered your question. I wouldn't differentiate between contaminant sources. Rather, any contaminant that enters the lake is of concern. It's a shallow water lake. And when it sinks to the bottom and gets resuspended, it becomes a concern again.
Thanks. And then we have a great question from Sean. What is the technical team's opinion on the contribution of impacts to the lake receptors, being shoreline erosion, sediment suspension, etc., from natural wave action due to storms in the open water season versus those from boats? Has this been studied? And do you think that would be a valuable undertaking to properly frame the contribution from boats?
Heather, I'll take the erosion part if you want to take the other part. Does that work? Or do you want to take it? I talk a lot.
I just was going to say, it's a very good question, and that there is a very big difference between wind waves and the energy that's provided by a wave train from a wake surf boat. The science on that is well defined and fairly easy to put your hands on. But if you have any difficulties, reach out to Lake Windermere ambassadors, and we can provide some help there as well. Basically, experienced shorelines are those that normally experience wind-driven waves. Again, they have a different energy profile than a wake surf wave does. The wind waves are striking shorelines that are used to it and experienced, so they're established to accept that energy, whereas wake surf waves come from all different angles, different shorelines. They're not aligned to the valley the way wind waves will be. So it's a great question. We're actually embarked on studying this here in the Okanagan, so we can see the difference between the precision, the energy between a wind wave and a storm wave and a wake surf wave. But it's a great question. We would love to study it here. I hope somebody's going to volunteer the funding to do that, but we actually have a process in play, Jamie and myself and some other folks that we're collaborating with. So yeah, great question.
What I wanted to say on that front was, in 2017, we had the major flood event that happened in the Okanagan. I did a lot of work for the city of Kelowna, cleaning up, helping the city repair their damaged infrastructure from the flood, right? My observations were that any anthropogenic or engineered site did not fare as well as any natural or vegetated site. Go figure, right? I like to poke fun at engineers sometimes just because I have amusement in it, and if I do, I'm just having a little bit of fun myself. But what is interesting to me is that on our urbanized shorelines, we oftentimes have a high retaining wall density or a lot of vertical hard edges. And Heather talks about that energy difference, right, between the waves. When you put up a hard vertical structure on a shoreline, that energy comes in, it hits the vertical structure, it causes toe scour at the wall, which is a problem, right? And at the same time, it directs that energy elsewhere. So if you have one property that has a retaining wall and this property doesn't, the property that doesn't have a retaining wall is likely to get erosion just from simply the boat wake hitting, and it'll continue to erode. It's why you oftentimes see erosion control, retaining walls, or riprap slopes. It just goes property to property to property to property, because once you harden it, that process keeps on happening. So I would encourage the lakefront residents and local governments around, as well as the province, to start looking at ways to soften the shoreline and help mitigate some of the recreational wake impacts, right? You start dismantling some of the retaining walls around that lake, you'll help dissipate some of that energy, and at the same time add a bit of riparian planting, other things. You also have habitat improvements.
Thanks. So next question, I believe may have already been answered, but we'll just go over it again. What type of boat disturbs sediments up to 8 meters? Is there a specific make and model?
I don't think it's a specific make and model. It probably comes down to the physical characteristics of the boat. So when you have a boat, right, and then let's say that boat has a ballast, that's going to push it down. Now you're going to put that boat under thrust. Oftentimes, particularly with wake boats, they don't operate on step where they come up and they're working through the water smoothly. They're actually pushing the water because that's what allows them to generate a big wake. So it twists down. You can see my hand, right? It twists down like this. And when you get that water pushed like this, they're oftentimes using a lot of horsepower to push the water. And that then creates the jet propulsion from the prop to push down like that. And that's how they measure that. When we say it influences things at 8 meters, substrate size plays a big role, right? Substrates that are this big don't get affected by prop wash unless you're in 2 meters of water. But know that I've seen full boat launches that have scour pools at the end that are 2 meters thick, right? Like I fixed one boat launch in the Okanagan that had a 2 meter scour pool at the edge of the concrete from simple prop wash. So that's helps put in perspective, right? And so it's not a maker model. It's the boat, the thrust, the horsepower, and how that angle and what that angle does, and then sediment size. Sediments at 8 meters would be very small. Your clays, right? You're very, very, very tiny particles. They're like, think about it like a mud puddle. You jump as a kid, you jump in the mud puddle, and it takes 3 days to clear up. All that really fine stuff that's sort of sitting in there on the 3rd day, that's the stuff that gets liberated at that depth.
Thanks. Next question. What are the stressors that are being seen on Lake Windermere? What scientific results come back that were outside of the expected results?
Luke, I think we should pick on you and boat density.
Yeah, fair enough. I mean, the boat density concern speaks to where we should be wary of disturbance, especially overlaid on that foreshore inventory mapping case. And that, I don't know if we're talking about the 20 acres for a single boat, it is important to take that nuance, like when we're talking about those maps of yellow and red hotspots. Those are kind of worst case scenarios when we're looking at the number of boats visualized, right? Because as I said, we're not taking into account purely recreating boats. So from that perspective, we're looking at a case where that specific concern, I think, is more of a safety issue rather than specifically speaking to any of these scientific guidelines, so to speak. So that would be more where that's coming into play for me, rather than, environmental guidelines or something like that, specifically for density.
Thank you. Next question. When you say all of the stakeholders were at the table and part of determining these recommendations, how do you define stakeholders?
Okay, that was just a misunderstanding. I'm suggesting that there be a stakeholder group, like a technical advisory committee or something like that, to establish a Lake Windermere stewardship plan. And so I would suggest that there would be a call for stakeholders to come forward and be present in that collaborative process. I'm not suggesting it is taken place and that ship has sailed. It's yet to come, so please stay plugged in.
Yeah, thanks, Heather. Are the findings from the study transferable to other East Kootenay lakes?
I think there are definitely portions of this that are transferable. There's certain portions that probably are not. Things like the boat density, like the methods that we use to count boats, definitely transferable to other lakes. The risks associated with sediment resuspension, those risks would still be present in other lakes. The conclusions about how many boats if there is potentially too many boats, probably not transferable without some actual count data. Some of the recommendations for how to manage recreation on our lakes are transferable. So we talk about the Lake Windermere water sustainability plan or water stewardship plan. You could apply that same concept to any other lake, right? And I encourage any of the residents that live around these lakes or local communities to start pursuing that within the Water Sustainability Act. It's a very powerful tool, and will allow all stakeholders to get together and talk about the good, the bad, and the ugly, and try and come up with a sustainable plan for the system, right? And it won't be easy, it will be hard, but everybody then gets benefit, including the boating community. If the boating community wants to work to assure that industry and make sure that industry has a place, then sitting at the table and working with all the different people is probably a good idea. Why? Because then everybody can figure out what the best solution is for your community. And I don't know what that answer is, right? I don't live there. I'm not impacted on a regular basis. You know, and that independence is probably good for the study. I'm not influenced or biased by opinions by being a resident.
Thanks. So we have another question here. Do you have any estimate as to how many human or wind-powered users can be sustainably accommodated on the lake?
It's a good one. My intuition says that you are teetering on your carrying capacities now at certain times. How you transition that to manage it is the interesting question. So, I don't want to differentiate between wind powered or fuel powered. I don't think it matters. I think the important point is the number of boats on the lake. Well, we use the example of Lake Tahoe. They had a problem, they had to regulate it. I would suggest that you are at a point when if you don't start thinking about what you're going to do, over tourism is going to kick in and you may have other consequences that you don't necessarily want, or you're going to have some strong biological consequences, a lot more cyanobacteria blooms or something like that. Heather, do you have anything to add to that? Or Jeannie or Luke?
I was thinking that I don't know if there's a specific guideline or scientific recommendation as far as density for human-powered or wind-powered vessels in the same way that we have for what we've found for powered vessels, but it may depend on what path the user group decides on. So, for example, if the playboat area is determined to be a useful tool, then maybe the carrying capacity for human-powered vessels would depend on how many, what area is actually left aside for that. But generally, I think that the impact of those is lower as far as sediment resuspension and those other concerns.
Thank you. We'll move along here. We're kind of running out of time. Can you comment on what happens when the resuspended sediments are flushed into the world-renowned wetlands?
Heather, that's you probably.
Well, we can only comment in a general sense. I mean, it's not ideal. Having said that, wetlands are fairly sturdy by their very nature, and they can handle some abuse. But is that a wise path to follow? I think you have a treasure here, which is both ecologically, I would say even spiritually and economically important. And I wonder whether the question should be asked, is there a risk here, or just simply how do we keep it as low as possible? Let's not go find out where irreversible harm occurs.
I think too, one other important thing is when the water leaves the system, if it has an elevated nutrient profile, it's likely occurring during the summer months when the active floodplain is not engaged. And that means that the beneficial aspects of the wetland in terms of nutrients suck up, right? They suck up those nutrients, turn into biomass, which is great, helps clean the water, if you will. You're not going to get that same benefit. And so all that's happening with that quick flush time is the problem is just moving somewhere else farther downstream. It's just moving and becoming somebody else's problem, right? What you may start to see happen downstream, if you were seeing elevated nutrient profile, is something like Didymo or rock snot kicking in. You might see other algal community changes, right? It's why Heather is a great person to have on the team, because the algal communities are oftentimes the first one to respond. They'll be a good indicator of, hey, we have a problem. We're seeing cyanobacteria increase on our beaches, right? Some of those early triggers are things to pay attention to. And I think that's what we're trying to say is that there is observable concerns here, and those triggers could start to happen more frequently and have an impact.
Thanks. We'll end with one more question here. Are there resources for developing a lake stewardship plan under the Water Sustainability Act?
I know that, oh no, she runs the environmental law. I forget her name.
The short answer is yes. Well, Jason thinks.
Yeah, there's a nonprofit out of Vancouver that has really been working hard to try and help communities establish this. I don't remember off the top of my head. 40-year-old Jason is not as good as 38-year-old Jason used to be. So, anyways, I will try and pass on that contact to you, Pam, and you guys can have that. Right. To date, there's been no community that I'm aware of that has embarked upon setting up one of those plans. But I do know that there are a lot of professionals out there that are encouraging communities to start going down that path, because it allows the residents and the communities to create a roadmap for what they want and where they want to go. The closest equivalent I have for anybody would be the LRMP, the Land Resource Management Plan process the province did in the late 80s, early 90s, I think, where they had these big blocks of land and they came with these resource management plans. It's a similar concept. So I can get your resources just off the top of my head. I don't know what they are. Apologies.
Thank you. So unfortunately, our time is running out today. So anyone who didn't get their questions answered, please feel free to email info@lakeambassadors.ca, and we'll do our best to find answers for you. So in closing, on behalf of the Lake Windermere Ambassadors, I would like to thank our consultants for being here today to talk with our community and for their great work on this project. And thank you to everyone who joined us for this webinar. For anyone that's missed today or wants to see a replay or re-recording of this webinar, we will be hosting an open house rerun on Friday, November 29th at 7:00 p.m. at the LWA office. Thanks again to everyone for joining us. Have a great weekend. Take care.
Thank you.
Thank you, everybody. Bye-bye.
Thanks, all.